Hello, let us talk about filtering by regex expressions. So if you saw regex before, this sort of thinking will be very similar to you. It is similar, the regex is about the same throughout different programming languages. What are we talking about here? So we can use a condition, filtering condition, where some expression not like pattern. The expression is the string expression, like varchar or char expression, and pattern is the regex expression that is done with characters, wildcard, which means any number of symbols, another wildcard that means one character. This is any number of characters. This is one character. Bracket means one character from the list inside the bracket, like A, B, C, D, and so on. You can use dash inside the brackets from A to Z, so that would be any single character from A to Z. And not, caret symbol means not. For example, not XYZ would mean that any other character except for XYZ. And carefully study all of these examples. They are helpful, especially if you see this for the first time. Where vendor city like San anything. So San Diego and Santa Ana will definitely fit this pattern, and hence in the actual SQL statement, this filter would retrieve the rows corresponding to these two entries. And let me actually stop here and make an example myself. I'm opening AP database, tables, and invoices. Actually, maybe I can start from scratch. I need to remember what is invoices though. So I want to choose certain invoice numbers, for example, invoice numbers starting from 9. And to make sure I know what I'm doing, I should also check the data types. So invoice number is actually varchar. So I can use my where like my like phrase and the regex that I will make. Invoice number, where invoice number like let's say the second digit is 8. So the first digit can be anything that is underscore, then second digit is 8, and after that there goes anything. So let's see what kind of numbers I will be left with when I run this. Yep, second digit is 8, and the rest can be anything, including completely differently formatted numbers or incomplete numbers without an area code, I presume. Okay, let's make it a little more interesting. We want numbers either 8s or 9s. And in the second digit should be 8 or 9. There is a first digit that can be anything, and then in the end also anything. Any length. Oops, I actually highlighted and tried to run it, so it didn't run. Okay, so our numbers, there are some 9s here, and yes, there are some 9s here. So you get the idea. You can do it in vendors to, for example, filter for certain patterns in the name. All right, let's keep going. So this is interesting. We can filter the states, and the code for the state begins with N, and then any letter from A to J capitalized, or for that matter, N and then not any letter from range K to Y. So the results are actually the same, interestingly. However, the search, if there are some small letters, they will not be forbidden. So small k is not forbidden over here. But obviously, if we're thinking about vendor states, there shouldn't be any non-capitalized letters, if our data is well cleaned, that is. Here is an example of the table. The above SQL statement only serves to like show what the table is, because it retrieves everything from it. And we are going to talk about nulls. So null means no value. Nulls are not equal to each other. And before talking about nulls, like checking invoice total equals to 0 fetches 2 rows, and checking invoice total not equal to 0 fetches the other 2 rows. So the only row that was not retrieved was row 3 from the original table. And now, in order to find all of them where invoices are null, you use isNull, or isNotNull if you want all non-zero ones. Okay, and more about ordering. Now, in this case, we have vendor name, and then we create a column consisting of address patterns like this, and then we order by vendor name. You can observe that the ordering is alphabetical dictionary ordering. That is called ascending ordering. The default ordering is ascending. And this is for ascending sort. So the smallest are nulls, then special characters, then numbers, then letters, the highest. And if you want to order descending, you are adding the keyword descend, this, and it is ordered descending. Now let's move to some more interesting, somewhat more interesting example. The columns are the same, I think, but they are ordered differently by vendor state, vendor city, and then vendor name. So first by vendor state, and we can see here Arizona goes first. After that goes California, and if vendor state is the same, California, then we order by vendor city. And lastly, by vendor name. So there is a variety of ways to order, and if you list more than one column to order by, the first has, like, you first order by the first column, vendor state, by vendor state in this case, then by vendor city. Within the same vendor state, we order by vendor city. Well, California is a great example here. First Anaheim, then Brea, then Fresno, and so on. All right. And feel free to look at more examples here. And this is an example that uses column positions. So we created this result, select vendor name and complex column as address, concatenation of 3 different columns, and then we order by the second column, that is address, and then first column by vendor name. So we can reference the columns by their respective numbers. The enumeration in SQL starts from 1. All right, and a couple of helper things, offset and fetch. So many first or sum. You can offset a number of rows. In this case, you offset 0 rows, so you skip after you ordered descending. You can skip some rows. In this case, you don't skip any, and fetch first 5 rows only. That way, you only return 5 rows and not everything else. So if you're working with a very large database and you want to test your query, you don't want the query to work through the entire giant database. You want to fetch the first 100 results just to see whether it works or not. And if you want, you can offset top so many results, say offset top 1,000 results, and then fetch the next 100 to see how the middle of the table looks like. And in this case, that's what they do. They offset first 10 rows and read the query carefully. So we order by vendor city, but our results actually don't start with Anaheim. We knew that Anaheim was there. Anaheim and the first 10 rows are offset. And I guess that's it with this about this chapter.